Hello student, I am Arnab Das. Today we discuss about the phase shift oscillator. For the phase shift oscillator, basically it is used for the audio frequency. That is, for generating the audio frequency, that time the RC oscillator, this is the example for the RC oscillator also. RC oscillator are more suitable. For the RC oscillator, their R and C are used for generating the phase shift, and the total phase shift occur in this case it will be 180-degree. Why? Because for a transistor itself it phase shift will be 180-degree. For the oscillator there 360-degree or 0-degree phase shift we have to record. So another one 360-degree generation, there another one 180-degree you have to record by the combination of the R and C network or circuit. In this case, their transistor PNP is used on there. Sorry, NPN transistor is used on there. And for the NPN type of transistor, there R1, R2, and RE are used for the biasing configuration. RL is defined for the load resistance, and the CE and the RE is combined form will be work for the bypass of the AC signal at the condition of the DC DC source. So now we have to check on that what is the way by which the phase shift oscillator work on there. Capacitor and the resistor, here number of 3 formation is added on there because we have to total record 180-degree phase shift due to this RC combination. The value of R and C may be selected in such a way that for the frequency of F, maybe we just consider here frequency F is generated on there. The phase angle is 60-degree. Their individual combination, this is R and C, it can generate 60-degree phase shift. So use the ladder network. Ladder network means one after one. It is connected as a form of ladder. And for this reason, it is ladder network is treated as there. So if individual one combination for the capacitor and R is generate 60-degree, so 60 into of 3, that is 3 RC section can desert 180-degree phase shift produce, and for this reason their total 3 formation of RC is used on there. Okay. Now the question is that why it is not written as a R R, this is written as a R dash, because for the transistor there the equivalent circuit, what will be the resistance value will be great, or the from the parameter also you can able to identify what is the internal resistance for the transistor 1 for that particular C configuration, and from that value of resistance if you add it with the R dash, that time this combined value should be equal to the value of R, and for this reason it is written as such. Okay, now we discuss with the equivalent circuit for the hybrid one. You already know about the for the transistor what is the hybrid equivalent circuit one on there. For the voltage divider biasing, their RC equivalent circuit is look like this. I just draw in here so it will be easy for understand also. So let for the this is for the equivalent circuit one. Here this is R of L. Um, Here this is I'm just writing on there for your simplicity. You just check on there is it is easy for understand or not. For the biasing configuration, this is look like this one. Okay, this one is defined the h of I, that is the For the CE configuration, the input impedance is defined by this one resistance value. This is the induced voltage source, and this is defined by H of RE V of 0. This is given on here also. This one is the induced current source. This is defined by H of FE of IB. And this one is defined for the admittance value, that is the 1 by H of OE, this one. And this resistor is defined for the R of L on there. And here another two resistor is for the R1 and R2 for the biasing on. Why it is not used in this position? Because here the assumption, or here the circuit combination you have to choose in such a way that parallel combination of this R1 and R2 will be work as a so high impedance value. So if it is so high, that means it can be treated that it is the open circuit one there. So if it is open circuit, that time you can omit this one section. This one section you can be omitted on there. If you omit this one section, that time the circuit will be look like as such. Look that if you omit this one, that time it will be just like this one. Here this is the here this is the H of E is present. This is H of E is present on there. Here H of E is present on there, and their value also given as such. And this is H of E is given on there. This is H of E. This one is the H of RE of V0 induced. This is H of FE. This is R of L, H of OE, and this is H of R of L on there. So this section you can able to identify. Now the remaining part of this circuit is capacitor and the resistor. This is connected as such on there. This is connected as such on there, and their R dash is connect with the base terminal. So this is base terminal is connected in this position. The base terminal is connected in here. So this is the equivalent circuit diagram for the phase shift oscillator. And for our simplicity, we use some assumption in here also. Let we assume that number one, their H of OE is very small on there. H of OE. That means 1 by of H of OE, its value will be large enough for this R of L. If it is large enough rather than the value of R of L, that time it can omit on there. Here this section will be not present on there. Okay, this will be work just like as a open circuit on there. Now the another one assumption is that H of RE induced the voltage source on there. Here H of RE is so small. If it is so small, that time their voltage drop or induced voltage will be so less. So it will be work just like as a short circuit on there. This will be work just like as a short circuit one. Okay. And for our simplicity also, we just assume that RL is equal to R on there. Okay, now check that what will be the ultimate circuit diagram. This is the short one, this is the omitted one. So here this is the source. If you convert source this source into the voltage source, that time this parallel resistor, that is RL, or it can be value of the R, it can be multiply on there. So this is multiply in this position. This is H of FE into IB into of RL, or it may be H of FE IB into of R if we consider RL equal to R on there. And this is voltage source and this is voltage source. The impedance value is the R on there, which is connected the series form. So this is series form, it is connected. Now that this section you just already covered up. Now this is capacitor is present. So this is capacitor one for this one, and the resistor is this one, this one. This is capacitor, this is capacitor, this one is the resistor, this one is the resistor, this is the capacitor, this is the capacitor. Now how you got this one resistance value? Look that this one is connected again at this position. This is the short one circuit, so this can be treated as this section, it is connected on there. And due to this reason of that, we consider r dash as a value of r minus of h of ie. So if we add with the h of I, then ultimate value will become on their r. So for this reason it is written as a r, which is connected. This is the short one, so this is connected in this position. So now the equivalent circuit for the phase shift as a Thevenin form, also it is named because we had convert the source, current source, into the form of the voltage source. So this is Thevenin equivalent circuit form for the phase shift oscillator will be look like this. Okay. So here their total number of loop is create 3. For the loop number 1, we consider here the current direction is clockwise and this is value is the I of 1. For the loop number 2, there the current is also the clockwise direction and the current value is treated as a I of 2 on there. And for the loop number 3, that time the current clockwise direction and this is I of B on there. If you consider for the first one loop, if you consider for the first one loop, that time their KVL if you apply, so it will be voltage is there H of IBR equal to R into of I1 plus of 1 by of JXC into I1 R into I1 minus, this one is the opposite direction, so this is minus R into I2 on there. So you can got the KVL, the expression on there for the first one loop. For the second one loop, you can consider the total voltage drop will be in this case 0. So 0 is equal to 2RI2 plus of 1 by XC into of I2 minus of, this is I1 is the opposite direction in this case, so this is minus of I1 into R, and for this R their opposite direction is the IB, so minus of R into IB. Same way we can got the expression by using the KVL for the third one loop on there. So ultimately if we write down these three equations for the three loop, that time there will be as such, and we just rewrite this expression as a form of I1 as a first term as a coefficient for the I1 is for the number 1 equation 2R plus of 1 by j omega c, and for the second one you can consider as a coefficient for the I1 is equal to minus of R, and same way here I1 is not present for the third equation, so their coefficient for that one will be 0 on there. And the same way you can write down for the I2 and IB also. So here these three equation can be rewrite as a form of the matrix. That time the matrix coefficient will be written as for the I1, I2, IB will be as such. Look that their I1 coefficient is 2R by plus of 1 by j of omega c. So here this is written on here j by omega c, 1 by omega c is the xc, so you can write down 2r minus of j of xc. Why this is? Because 1 by of j of xc, sorry, this one we are considering 1 by of j of omega c. Why this is written as such? This is can be written as a form of j. If you come to the upper side, then it will be minus j, and this section is defined as a xc. So here you can write down 2r minus of j of xc, and then for the I2 the coefficient is minus r, so write down here minus l. Now for the IB, that time the coefficient is given as a h of fe into of r. Look that h of fe into of r, here this one. The same way for the second one equation from the second one equation I1, their coefficient is the minus of r, so it is written as the minus of r. For the second term, for the I2, the coefficient is 2r plus of 1 by of j omega c. So this one can be again write down as a form of 2r minus of j of xc. And for the third one, this is r is the coefficient minus r, so you can write down minus of r as a coefficient for the I of b. So same way, this total matrix form can be identified, and from there what will be the determinant value? The determinant value will be as from this one, so ultimately solution will become this one. So from there, this is the ultimate equation if you write down as a form of simplified one. So this will be the ultimate equation. So there imaginary and real part is present. From the imaginary part, if you check on there, this is the imaginary part is there, this one section. So here j of xc cube equal to j of 10 r square of xc. From there you can write down this is x cube is equal to 10 of r square of xc. So from there you can get the value of xc, that is 1 by of omega c value you can got it. So if it is 1 by of omega c is this one, so from there you can also calculate the value of omega on there, that is omega is equal to 1 by, in this case, root 10 of rc, and omega is equal to 2 pi of f, because omega is equal to 2 pi of f, so f is equal to omega by of 2 pi. From there you can calculate the value also f. So this f equation will be 1 by 2 root over 10 pi of rc. So this is the frequency which is generated by the phase shift oscillator on there if individual resistance value is treating as a r and c also with the same one. And if we consider that RL is not equal to R, that time by using the same process, you can able to got the answer for the what will be the frequency it will be generated, that is will be f is equal to 1 by 2 pi c root over of 4r RL plus of 6r square. So this way you can able to identify for the phase shift oscillator what will be the frequency it will be generated on there. And the third one is that you have to identify what will be the criteria or condition you should be fulfill on there to maintain the oscillation process, and that one can be got it from the real part of this equation. From this equation you can able to real part, so you just omit this two section. So this is 4r cube minus of 6r x cube plus h of fe r cube is equal to 0. This is written in here also. So from there you can able to identify what will be the value of h of f. H of fe will become as a value of 56. So this is the condition, that means you should have to choose a transistor where h of fe is equal to 56 for maintaining or sustain the oscillation by using that kind of circuit diagram, that is the phase shift oscillator. And I think this is enough for this phase shift oscillator, and next we come with the new topic, and till have to say good day and bye.